Well, hi, good morning, and thanks so much for joining me here in my shop for another day on this radio. My primary objective is to get it working to any degree. I suspect there's something wrong with it, don't know what. It's possible it's just so badly aligned it's not working well. That's not very likely, but it's possible. That's kind of what I'm going to try to chase down today. In the course of poking away at the alignment, I'm liable to uncover other problems, or the other problem if there is one. So I think that's a pretty valid approach at this time. In my world, first time you do an alignment on a radio is generally a write-off anyway, because you're in the process of learning how to, all the wrong ways to do it. But let's start by looking at this speaker, because I was just looking at it now before I turned on the camera, and I thought, there's more to the story here. I got bits of the story already. Part of the story is, let me just grab my camera here and do this the lousy way. So these wires are all cut and soldered in. That's a sign that this is not the original speaker. Number two, look at this. Well, what's going on with this? Why is this like this, with this exposed? It almost looks like that's from some other speaker. Look at this arrangement here. This is really odd. This is roughly cut with a hacksaw. What's going on here? Now, there is a big metal can. You know what? Maybe the can fits right with this. Maybe that's what it is. They had the can on. I'm looking for the can now. But put the can on there and then painted it. That's probably the answer. And the can, here's the can. The can is right here, for crying out loud, within view. Oh no, this is going to come right out to here. Well, it could just be a manufacturing practice. They want to keep this clean, no paint on it. So they cover this when they spray paint these parts. Maybe. Or this is two speakers cobbled together somehow. It's hard to believe. I didn't point this out. On top of this transformer here certainly is not original. It's only screwed in with one screw over here. It's just hanging. It's just hanging here. So exactly what's going on with that speaker? There's a history there that we don't know. Now, is that going to have any bearing on anything? Probably not. But I think it's important to become aware of this kind of stuff along the way, so you have it in the back of your head as you're doing other work, just in case there is an implication. And what would the implication be anyway? Incorrect field coil resistance. What would that result in? Incorrect B+ voltage. Too much heat in here. Too much hum coming out of the radio. Not enough B+ voltage. Something. Who knows? Who knows? Now, and distortion in the sound is possible too, obviously, from the speaker itself. So I was going to restore this to the way it was, which is just shorted together. Now, this radio has a bottom plate, and alignment really should be done with the bottom plate in place, but I'm not going to do that because the first time through is just kind of a checkup anyway. And if you get it, if you align it without the plate, the radio is aligned without the plate. It's fine until you put the plate on. As long as you don't put the plate on, you can call the radio aligned. It's if you align it without the plate and then you put the plate on, then you've got, once again, improperly aligned radio here. Okay, this isn't exactly the most high-tech way of doing this, but that's going to do it. We'll just leave that there. So that imitates the link that's missing back here. Okay. Right, so we're going to just jump right to doing the alignment. So the alignment is going to involve, let's see, I've got this meter connected up to the speaker so we can see the output level. And this guy is measuring that minus 50, which we're not too concerned about right at the moment. whatever that was. Oh, that's right, that meter sticks. Oh, as you notice, it came up and went boom. It sticks here because there's something down in there. Let's deal with that. I'm going to take that faceplate off. It looks easy. Now, what I've discovered is, of course, these screws go into nuts. So they're dropping off the back. Now I'm still going to continue. I'm going to trust the screws are going to drop harmlessly to the bottom, the nuts rather. I can pull out on the screw a bit. That's going to freeze the nut, and I should be able to back the screw right out. The nut will drop. See, that one didn't drop. Uh-oh, this is going downhill rapidly. I have the switch off, by the way. Yeah, going downhill. Never taken this off. No idea what would... Oh, there's no zero adjustment here. Looks like the whole meter's coming, not just the face. There goes the nut. So I'm not going to be able to use this meter now because one nut didn't drop to the bottom. The one from here just dropped short distance. Who knows what it's caught on, and this may not be this may not have been the smartest thing to do. I have another meter, so I'm not too worried about it. Now the meter face is loose. I can pull it forward. I think the whole meter's coming out here. This is not what I was counting on. Did I think I was going to be doing this today? No. Mark these. Okay. Down there. Okay. So I took a meter apart. Just a couple weeks ago and pretty much filled my pants while I was working on it because just about everything you wouldn't want to have happen happened. Somehow I managed to get myself out of that huge snafu and save the meter. But here I am again. What happened to the top screw there? Here it is. June 28th, 1960. Okay, so 4 screws here and the front plate will come off. Small diversion from my plans today. So this is a well-known meter, this Hewlett-Packard meter. There's probably tens of thousands of them around. It's a great, if it's working well, it's a great instrument. Typically used in audio situations where you're trying to control audio levels. It has an input and an output. My understanding is as long as you keep the meter movement in the middle of the range, the output here will be of a certain sort regardless of the input. So the input's going up and down, you're snapping this to kind of get it into the middle range, and then you've got a nice output to carry on standard output, so many milliwatts into 600 ohms or whatever it is. Whatever it is. Okay, here we go. And this meter will also go up to 10 megahertz accurately. Like there's a really obvious thing in the way there. So how did that get there? Okay, so let's get the close-up camera on this. Oh, I have to go get it. In the world of video making, this is a difficult arrangement I've got here. Dark color covering about half the screen with a very bright color here. So to get it to look the way you see it, I've had to darken down my shop a fair bit. It doesn't look dark on the video. It's dark in here. Okay, now the fact that I can't see doesn't matter. Let's use that camera and take a closer look here at what is going on. Because okay, I gotta do something. Oh, focus. Okay, give me 1 second here. It's going to take me a moment to fix this up. The autofocus is on, which is really not a very good way to do these videos. So I take manual control over it, like this. Okay. So I'm looking for any parts that just look to be bent out into the wrong position. So there's the 0 screw. And this is the lever that you would normally use. It's got a wire soldered onto it. I've never seen that. But this lever normally has a little thing that engages from the top here, from the front of this meter. Again, there's places for there to be openings to mount a 0 adjustment, but there isn't one. There's no 0 adjustment. So the 0 adjustment is done. Oh, you know what? You can't really zero these meters either, because there is no 0. This is a logarithmic, meter. Turn it this way. All right, it's logarithmic. Weston must be Institutes. Weston Institutes, division of Daystrom. Wow, who owns who? Eh? There you are, 1 milliwatt into 600 ohms. So it says HP here. It says Weston up here. That part that says Weston, I think that's hidden from view when you put the top on. You just never know. This is a metal plate. Put a little bit of cardboard on top. What are those guys? So that's the bumpers. What's all that down there? Like a little copper coil on a stick? I haven't tried moving anything yet. Look at all these little parts in there. Counter, that's probably a counterweight right there. And the wire wrap may be the way they fixed it in place. And the wire wrap on this thing may also be a balance technique they're using, so they somehow wrap enough wire on to give a balance. You could put weight on, you could put it towards the end, towards the middle. You could get pretty fancy with making adjustments there. in the manufacture of this thing. Now, why? I guess they're soldering the wire here because this is the way into the movement. The coil that's in the magnet there that rotates, the moving coil. That's the word for it. It has to get electricity to it, so it's got to come through these pivots. Unless I have an incredibly light wire hooked up, which can't be done really. I don't think you can do that. Or it's got to go through the spring to get there, which I don't think is the best idea either. I don't really know how they manufacture these, but I think that's what we're seeing. There's a whole bunch of balancing issues. Okay, so what I see stopping it is that bumper. Well, I'm gonna move the pointer by hand now. Geez, the last meter I bent the living daylights out of the pointer without even knowing I was doing it. It was so light. So this is coming up, and it's hitting that. Now, so I think what I'm seeing there is the attachment to the end of the spring and the spring adjustment. But how did it get in the way? No one's ever been in here, unless my cats are doing this. Let me see a little further down in there. I could just get a little bit better light. Okay, let's try that. You can see pretty clearly now it's the outside of the spring. That's typical. When you adjust the zero on these things, you're actually adjusting the end point, the movable end of the spring. Why wouldn't I just push it over to the right? Get it out of the way. Well, that would, like, this is a precision meter, and that might end the precision. Now, in my shop, nothing's very precise, so does it really matter? Maybe not. There's nothing here that is showing up. Now, isn't that supposed to pass under it? I would think they would make this so the meter arm down there would pass under that thing. How close is it? Is it really hitting that? Is it hitting something else? I think it's not that. I think that's coincidental. I don't think that's what it's actually hitting. It's quite a coincidence. It's right on the money. But they would have designed this to go under. Okay, so if I push past it, what am I doing? I don't know. There's something else that's... Oh! What's that? What's that thing? Why, that would look like a piece of debris that has fallen from somewhere else. That's it. That's the problem right there. Where'd that come from? So this has to come from inside the meter somewhere. So it's a screwed in thing. It's a clip, like it's a metal clip put on a post, spring clip. You can kind of see the bend in it. So it's constantly pulling that post away from the surface, and they glued it. But it managed to fracture that surface. See that? This is like an airplane accident here. Huh. Anything else look like that in around here? Did I see anything like that? It's missing. Now it's missing in action. What would that be for? Let's flip this over here. Oh, the pointer is exposed. Pointer exposed. Just a little too bright for my camera here. There we go. did that on its own. Okay, we're looking for things that look like that thing. Things that look like that thing. Looking right down the crack here. So it showed up here. It kind of couldn't have come out of the meter, like the back is all sealed. The only way in is for something behind here to have come out. Well, for all I know, that's a piece of debris that's been in this meter since the day they made it, and it only recently managed to fall into a position of interference. Okay, so that story's over. I'm going to put that meter back together. Pretty happy about that. And we'll get back to what we're doing here. I almost forgot I have to get the mounting nuts. I have to recover them. Hassle extraordinaire. What's coming off? The whole thing comes out the front now. More screws. There we go. Okay, out a little bit. Oh, now this is still plugged in. No, it's turned on. I think we're okay. Famous last words. Okay, is that far enough to get the screws out of there? Any falling out yet? I'm going to drop straight down, be right back here. Okay. It's not working out so good. Okay, I got to stop. I got to pull the plug on that. And so just in pulling the plug out, it gives me a chance to show you something here. That's the plug for that instrument. It's a 3-pronged plug with only 2 prongs left. When I obtained the instrument, which came straight from the testing shop where it was in a radio station. In fact, if you look at the top of it, there's a sticker on it. It says CHFI. So why would somebody do this? This is not a stupid thing to do, and there's certain circumstances. So for an instrument like that, perhaps you'd rather not have it grounded. You may be operating your bench in an ungrounded, isolated situation. You need to do this kind of thing to avoid introducing a ground. Now my shop is grounded. All the equipment is grounded. But this one isn't, because this is missing. Well, it is grounded because I have a wire, kind of a maybe too light of a wire. This little wire here, you can see a bit of it here going up to another instrument. I've connected all the cases together of all the equipment that's in here because of this. Because you don't know. I mean, well, you do know. You can use your own equipment, so you look at the plug. But these things got to be thought about. I'm very careful to make sure I don't plug this in backwards, because you see there's no control here. It's the 3rd prong that's controlling this, so you have to make sure you put this in properly, not backwards. Not sure what the consequences would be, not interested in finding out. Okay, so there you are, power plug. Look at that meter hanging out there. I gotta fix that. Okay, so I've recovered 3 of the 4 nuts. 1 nut is still in there somewhere. I've screwed this back in with the 3 I've got, so I can do stuff like this. So that suggests to me the nut is already out. It's on my bench and I missed it. That's what that would suggest to me. I don't see it. Did it fall in here? Maybe it fell in here. Where are you, nut? I'm a little anxious about running this with a nut lost inside it. Okay, I got to get a little more intense here. So it would have fallen into the front and gotten pinned somehow. And flip this thing right over. How can this kind of thing happen here? Okay, I'm going on a long hunt. Let me take a close look at that guy. Maybe I can spot the nut. It's probably just stuck in there somewhere. But it's an interesting device. Oh, my camera's on the floor. Huh. We'll take a close look at it here. Whoops. Oops. There. A very close look. This is a very high quality instrument. Lots of wire wound resistors in here. Very looks like they're handmade for this guy. That's what they look like. I've never changed a part in here as far as I can remember. Everything is original in this unit. A little yellow cap on the top of the tube. Not much to see up here. Now we're looking, let's see, so it would have fallen from back in here, right out of that hole, downwards, down here. There's really nowhere for it to get stuck. Is there? Huh. Let's look at the other side of this guy. More interesting side here. No, doesn't want to fall out. Okay. Again, very, very high quality. I'm going to change the focus here. It's just a little bit too close. Let me bring it out a bit. Wonderfully done. That's why you pay money for these. Keep your eyes peeled for a nut laying around where it shouldn't be. Yeah, I'm looking for any obviously defective components or anything like that. They all look wonderful. You can guess that this is a high mileage unit. It did a lot of work in its day, but with me I haven't used it too much. It's had a lot of trouble with the selector switch. There's a big fat capacitor there that's probably due for a change. A lot of resistors in here. See that resistor with a wire wrapped around? That's got to be handmade for this unit. You see any nut loose in there? I think the only nut that's loose in this shop is me today. So could it even fall? It really wouldn't even fall back here. It's going to fall in the direction of the camera, downwards. Like this is one of them here. So if that's the one, it would have fallen, like it didn't fall far. So maybe this is the one. It would have fallen on top of this. Surely to goodness I could have shook it off that by now. This is going to drive me nuts. Spend all day looking for a lost nut. Now it could kind of bounce out into this area here. Whoa. A little more dust down in there. Here, little nutty. This is easier to see out this way. It's very unlikely to have made it over to this area. It fell a little bit and then just became silent. It didn't click its way to the bottom. There's that molded capacitor again with the... Oh, for crying out loud. It's out on my bench somewhere. Pretty sure of it. Look at this little light bulb here. Can't say I've seen one like that before. Could have got caught around here. Get caught in behind a wire like this. Oh my gosh. Well, a close look shows the instrument's in great shape here. What to do? Am I just going to forsake it and say, well, it's on my bench somewhere. It's not stuck in anything that's going to cause a problem. Go ahead. Use this meter. I'm going to take another look on my bench. I just can't let this go. I'm so concerned about what happened to this nut. Oh, it's loose. I think it could have fallen inside this can. Assuming I can get this can off. See it there. Underneath it. Spend the whole day on a goose chase here. There it is. There it is. Okay, I feel a lot better now. Okay, I'm going to get that, finish putting the thing together. Yeah, up under there. I don't think I'm different than anybody. Busy putting the last two screws in, and I look over and go, what are those? Then I realize, oh, for crying out loud, I forgot to put the cover plate on. Yeah, that's par for the course here. So the alignment instructions say, feed your signal generator into the control grid of the 6A8. And that's just a little bit vague because there's two control grids on a 6A8. So control grid number 1, which is closest to the cathode, is normally fed from the oscillator. And then grid number 3 is the signal grid from the antenna. Which one am I supposed to hook up to? It may not make a lot of difference actually which one I pick. I think I'm going to pick the signal grid. That would be grid 3. Grid 3, well, that's the grid cap. Let's see, 1, 2, screen, signal. We're going to feed it into the grid cap on the 6A8. I use a 1 microfarad capacitor, and we can go in right up here actually. Okay, here comes the signal generator. I'll start with a fairly low signal, but usually it takes a fairly strong signal to do this kind of thing. Whoop, 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 that's the wrong way. Let's wait until we get the radio operating. And so then I also am ready to connect the speaker here, but I haven't done it yet because I think one of these two is grounded. I'm not quite sure. We'll figure that out in a second here. So I guess it's time to start this thing up. Any reason why we need the indicating meter there? No. Okay, I put my little workman up here. Now, in the instructions, it revealed that the broadcast band is when you have the selector knob all the way clockwise. So this is on the broadcast band. Not 100% sure about what's going on with the antennas here. We don't need to worry much about it right now. I think it said tune it somewhere where you don't get any interaction. What it said, and keep the volume up full during this process. Let's turn it down to start though. Not that there's a lot of volume coming out of this radio. Okay, we're ready. Forgetting to take my phone out of my pocket there. Normal, give it the full supply. Well, we're still going through the dim bulbs here. No, we're not going through the dim bulbs. I'm still restricting it here. Put this up where it should be. So we're at 114 here. We'll go just a touch higher. 117. There we are. Okay. The standard supply voltage. What do we hear? Well, you can hear a little bit of noise when I work it, so there's something coming through. I think I hear a very low pounding hum right now. That's a good thing. That's good. Everything we're working right, we would hear a tone coming out of here right now. It's on the antenna, that's not where you put it, bozo. Hey man, get your act together. Hey, just experimenting, that's all. Maybe we'll hear it now. The frequency's off, alignment's off, signal too low. Something else wrong. All those possibilities. Okay, let's get the meter hooked up. Now, when it warms up, you should throw it all the way over. Let's see if it does it. Come on, meter. Don't let me down now. The little light didn't come on. How come the light didn't come on? Son of a gun. Okay, now it may stay pinned because there's actually a signal reaching it, a noise signal. So the other thing is the switch in here, the contacts are dirty, and you get that kind of effect from it all the time. As much as I like this meter, it's a hassle to use it. So let's short the leads to it. It's a very sensitive meter. That's good. Now there's no zero on these meters. Perfect. That's good. I'm happy with that. We're going to guess 0.3 volts. Now the radio's operating. Carry on. Oh. I scared myself. Okay, that's good. Because we don't hear anything, there must be nothing reaching the speaker pretty well. Okay, let's fool with the volume here. So you saw the meter just jump there. It proves it's hearing what's on here. Now we got to get something coming out of here. So I'm going to up the signal generator strength. You can see the frequency we're on is 455 here, means 456 in fact. Go up by a step of 10. Another step of 10. And there it is. And that's good. I mean, it's good the radio's working. It's not so good that the radio's working. Okay, let's see what we can do with this. Now, chances are it's aligned pretty well. What do we got in here? We got capacitors with screw tops. I'm actually going to try a metal screwdriver. See if we can get something up on the meter here. Okay, now is that... Is that really the sound we're hearing? So I'm going to increase the sound level and see if the meter doesn't follow suit. The receiver's turned up full, but I can do it over here. Okay, so that's convincing. This to be at 30% modulation. And why don't we take a minute and calibrate this? It's very close. Not that it matters when we're doing this particular test. Okay, now I'd like this to be a little higher. Come up a little higher. Not very convincing that this is reacting to the sound level. Do I really have it turned up all the way? Maybe. It sure seems that way. Maybe I'm toning it deaf here. No, that got less. Well, we're going to have to work with that. Oh my gosh, it's almost off the scale. Okay, we'll start with this one. Screwdriver right in front of the meter. My two-hand rule here. Okay, here we go. Watch what you can see of the meter. Here it went up briefly. I can hear it more than see it. Pretty close. We can't use a metal screwdriver on that one. Now, let's see if this will engage. Nope. Okay, we'll try this guy. Whoops. Try this guy here. Okay. Now, did you see this tool bend before it went and then you heard a little pop? This is a bad way to align radios. Ooh, ooh, ooh. Let's try that. This thing started motorboating. Probably not good to keep it up there. Well, this is revealing another problem in the radio, I think. I get motorboating like this. leave it motorboating. Motorboating is it? Oh, now you can't see here. Motorboating is a form of feedback, usually involving the, like this kind, involving the ABC circuit. We found a really high negative voltage, 50 where there should be 25. You know what, I just can't do it with this weak and flimsy thing. Even though this metal's going to disturb this a little bit. Where'd the motorboating go? This is screwed right down tight. This was screwed right down tight. I say that one more time. Ah, this is 10 miles out. Somebody has come in here and tightened these up. They were loose. Something funny going on here. Why is this not... because I'm feeding the signal in way up here. It's here, 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 then here. Start with this one, and then go to this one. I'm doing this right. Why some more signs of trouble in this radio, maybe. I mean, that is part of why I'm doing this alignment thing right now. It's just a... Yeah, this was tightening. Oh, it's another peak. No. You know what that was? That was a screwdriver touching the can. No proper peak on this. You shouldn't be able to turn these things this far, you know. This is not working right. Let's try the other one. I think we may have kind of zeroed in on the problem here. Maybe. Okay. Wow. So these trimmers, capacitor screw type trimmers, you know, once you crank them open a couple of turns, they're just, you know, they're at their limit. There's no sign of a peak coming. We're still on the right frequency. It's not peaking. Then let's, why don't I feed the signal in here through this one. Let me turn it down a notch, maybe 2 notches. I'm going to move this from here to here. Back up. Get it up to the same level on the signal generator, even though I'm skipping over a tube and a coil. You'd think you'd need much less signal at this point. Okay, we're going to try this again, although it should be fine. I really got to come up with better camera angles here. Now that's normal. That kind of tuning, that's what you expect. Very distinct peak. So I think we got problems in the first IF circuit. Yeah, see, I did get this right. It doesn't make much difference if I feed the signal in up here or here. Shouldn't make much difference on this. This guy's going nowhere. Let's give him another try. So that seemed a little bit louder, right? Let's watch the meter. Floating between 8.8, 8.9 on there. A little lower. So there is some action in here. This is just so far out. I'm zooming past the resonance point. Which is not very likely. pretty tight. Can't get much tighter than that. This is a bad sign. This is definitely, so this would explain weak radio everything. If this part is not working properly, something in here is messed up. There we are. It gets quieter, louder, and then it just doesn't. Well, I think we found basically where the situation's going south. Oh, what happened there? What happened? I didn't hear any sound changes. My meter lose its grip on things? Yeah, I think my meter just lost its grip on things. Just like me. Okay, that's interesting. I think that's going to be the topic tomorrow. We'll focus in on this area here and try to sort out what might be wrong about it. See if we can't bring this guy to life. Hey, why don't we try? Yeah, you would need more signal. I'm trying to think of what it is I thought we should try, but I can't think of anything now. Feeding in a regular radio signal. Feeding in a regular radio signal. Put this back here. And we'll tune the signal generator to roughly where the radio's tuned. Where's the radio tuned right now? About halfway up the dial, about 900. So we'll go up there. Okay, that didn't really. Oh, we need this on the. No, I want to feed it in here. This is exactly what I want to do. Let me just check the tuning here. Make sure it's down under 900. Okay, so we're 850 on the dial. So I am pile driving this thing with a signal stronger than you would ever get off an antenna. The volume is turned up absolutely full. You can barely hear it coming out of the speaker. Now because the signal's converted right after here, I can't just move this, you know, and skip over the weak skip over the weak. What I could do, what happens if you do this? That's pretty interesting, and nothing happens. Yeah, that's got to be part of the picture here. Okay, so the whole deal, I guess tomorrow is the front end of this radio. What is it doing? What is it not doing? Okay, that's progress today. Got my meter fixed. That's good. That's good. Thanks a lot for watching again, and I think I know what I'm going to focus on tomorrow.